Hi, Mr. Hayes here, Hayes' World of Math. We're going through a 3-week course that a friend of mine, Christina Mallon, and I put together a couple years ago. The link to all of this, both the Word versions and the PDF and the answer keys are down below. All of this stuff was taken off the AP website, so use it as you would. I've reformatted it so that the questions are exactly how the questions were on the actual AP exam, as opposed to the condensed version that you will see on the AP website. So I find that that's helpful for my students. And then everything else is pretty much as normal. So I want to go through some of the ones from Unit 2. This is actually, I should say, Chapter 2 from the Practice of Statistics books. I will try to go through 2 or 3 problems every day for each of these, so you guys can kind of double check where they are. I usually go through the first 2. I provide oftentimes extra problems, just so then that way my students can go through them if they want to have extra practice as they go through and they see places where they hit. The other thing on the course down below is there's also links out to Khan Academy topics that can also I used for my students to preload so they can kind of remember things. So like in this case, they were doing standardized testing and things like that. So anyway, here we go. Let's take a look at the first question. And the first question over here is this. Professional sports team evaluates players from a certain position based on 2 main characteristics, speed and strength. Speed is measured by time, how long it takes to get them to 40 yards. Smaller times indicating more desirable or faster speeds. From previous speed data for all players in this position, the time of run of 40 yards has a mean of 4.60 seconds, and the standard deviation of 0.15, minimum time of 4.40 seconds. So the first question that they're going to ask, and I believe there's 3 in this part, is this. Based upon the relationship between mean standard deviation and minimum time, is it reasonable to believe that the distribution for 40-yard running times is approximately normal, and explain? So what you'll need to do here is decide, is this normal or not? So take a second, hit pause, write down a couple thoughts, and I'll tell you what the solution is here in a second. All right, so the first thing, if it's going to be normal, we have to kind of see where the z-score would fall, right? So what would the normalized score for that minimum be? Because if it's down like 2.5 or 3, then we're like, okay, yeah, it's probably somewhat normal. But as you can see here, now notice, just like what we've talked all year about, I've got general formula, numbers plugged in, away we go. Actually, I don't have the, general. So if I type this in, I get a negative 1.33 for my z-score. That's the minimum, okay? So now our minimum value is only 1.3 standard deviations away. So there's a whole bunch of, you can say that a whole bunch of different ways. So it's obviously not normal if that's where the minimum is. And the one thing that I would go on to say here as well, okay, is I would go a little bit, so there are no scores less than 1.3 standard deviations below the mean, so therefore it can't be a normal distribution. I went on to go through and say typically 9% of the data is, sorry, I should have said it this way, is less than, 1.3 standard deviations below the mean. So that just kind of gives it, again, some kind of context. Okay, so we're missing almost 10% of the data. Normally 10% of the data would be less than that, what that minimum score would be. Okay. So then in question part 2, okay, for the second page then, or for the second part, they're doing strength, same idea. Now they don't give us a minimum or maximum, and they're asking us to find a z-score. So they give us the mean of 310 pounds as the mean weight lifted, and the standard deviation is 25 pounds. So to calculate this out, now you can see I have the z-score, x minus x bar over standard deviation, blah, 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 blah. I get a z-score of 2.4. So we're saying that this player is lifting 2.4 standard deviations above the mean of 310 pounds, which is, obviously significant. I went on to say, even though this isn't necessarily, I try to go through these before I look at review the answer keys in here. I went on to say saying that this was 99.1%, more than 99.1% of all players tested on this. And then I left it down here, what a calculation to get that. So I did normal CDF, negative 10 to the 99th power, upper value is 2.4, mu is 0, and sigma is 1. So now the big part, they're going to ask you to compare 2 different players. Let me get there we go. And then, so to compare the two different players here, they're going to say, all right, you got two players. You can only pick one of them. And they give you both the run times and the 40 yards for it and the amount lifted for both. And you're supposed to use the information, the mean and the standard deviations from the previous two parts to go through and do this. So the setup here is that you should find normal scores for both of them in terms of how far, well, I shouldn't say normal scores, how many standard deviations away they are on both of those. And so when you go through and do that, I ended up calculating out for the run, the first player, and I have RA and WA and RB and WB down for these. So for the run, the standard deviations was 1.2 and a negative 1.2 standard deviations below the mean. And the second person was running negative 0.2. So they're both faster than 50% of the people. For the weightlifting, the first player got 2.4 and the second person got 2.6. And so they're both much stronger than your average player. So now when it comes down to who are you going to who you're going to justify who to pick, what are you going to say? It comes down to this, and I'll show you what I've written down here in a second. But if you look at the weights, even though the player B is stronger than player A, they're effectively kind of the same. It's a difference of 5 pounds. It's 2.2 standard deviations. However, if you look up here at the running, player A is 1 full standard deviation below, faster than player B. Okay, and so that's what I ended up going through and saying, and what the answer is actually. So both players are faster and stronger than normal, as indicated by their z-scores. Player A is 1 standard deviation faster than player B, and player B is 0.2 standard deviation stronger. Since the strength scores are close, player A is the better option, as they are significantly faster than player B. Okay, so if you did all of that, that would pretty much get you a essentially correct and 4 points on this one. All right. Now the next problem we go through is this. This one's a little bit more straightforward. So they go through gasoline prices and they give you this, and they ask you to go through, and so this is all the state taxes, since the federal taxes are all the same across the 50 states. And so down here they're saying, okay, they ask you what the median is and what the IQR is. And they're asking you to mark it so they can make sure it's clear to where you're getting it from. So the median is right here. So that's about 21. Make sure that you understand that this point right here is 2.5. So 20, 22.5, 25. And then the IQR is running roughly from 18 cents to 25 cents. So that would give you an IQR of 7 cents. Easy points, right? Great. For part B, they ask you, now what happens if we add on the 18.4 cents for federal taxes? How is that going to change the median and the IQR? And you need to go through and you need to explain that the median is going to increase because all the values are going to go up by 18.4 cents. So everything moves up, which I have down here. So the new median is going to be 39.4 cents. Now the IQR is going to stay the same because everything's moving up the same amount. So the range is going to stay the same. So in this case here, the IQR won't change because both Q1 and Q3 are going to each be increased by 18.4%. Now to be safe, I went down and I showed both of them so that they're moving to 36.4 cents and 43.4 cents, but that's going to give us 7 cents, still give us a 7 cents IQR. All right. And that is it for that question. So that one is actually, much faster and safer than most. And again, that was from 10 years ago? We haven't actually had something specifically from this. And I think it's been at least 10 years. So, and these are some of the types of questions sometimes you can actually cover on multiple choice questions better. But anyway, hopefully that gives you a better idea of how things are going. I believe there is one more in here. So that is left to you. Again, the answer keys and everything else is down below. I hope you find it helpful. And if so, subscribe, like. We'll continue back with Chapter 3 tomorrow, and hope to see you then.